Okay, let's continue number 20. So this was our integral, our equation, and we want to integrate the left and the right. The right-hand side is very easy, right? We have this expression, but here, this integrand, we need to use partial fraction decomposition. So we know we want to rewrite it as follows. And then we did some work and we found our a and our b. So now I basically want to substitute my a and b. So if I substitute my a and b, I obtain the following. So on the left hand side, so I have the integral of, let's see, let's go ahead and do it in pink here. So negative 1 over m, right, times 1 over p plus 1 over m. And then I have my other quantity here, and we'll just say dp equals at plus c1. Now remember, a and b are just constants, so I can use a constant multiple rule, and I'm going to factor out a 1 over m. You can factor out a negative 1 over m, but I'm just going to factor a 1 over m. And so when I do that, right, I'm just left with the following. So I have, let's see, 1 over, so p minus m minus 1 over p. So I kind of just swapped these, right? I brought this guy over here and this guy over here. And let's see, so we have, again, the same thing on the right-hand side. And this is very, very nice. And actually, I don't want to forget my dp. So 1 over m, and now again we can split these guys up. This is really dp over d minus m minus, let's see, the integral, well, this one's not too bad, dp equals, okay, right hand side, and now I have 1 over m, and this is a nice natural log, right? Natural log of p minus m. Minus natural log of p, right? Remember our independent variable is p. So we have, right, f prime, right, the derivative of p is 1. So we have 1 over this guy. And again, you can use substitution if you'd like. And let's see, finally we have equals. Well, let's just keep writing this guy. But I have my 1 over m, and so I'm going to multiply both sides by m. And okay, so let's go step by step here, since you will definitely be seeing this process a lot. So it's good not to skip steps. So I have m, let's see, times at plus, I'm just going to call this c2, where this guy is m c1. And we have natural logarithms, so we can definitely use the logarithmic properties, specifically the quotient rule. And the quotient rule tells us that the natural log, so we have a difference, so we definitely have p minus m over p, and this guy is the same, plus c2. And we can exponentiate both sides. So I have, right, we're exponentiating both sides because these guys are inverses. So I'm left with this quantity, and I have the following: e to the m at. Well, we can technically rewrite this. Okay, let's, again, not skip steps. So we have p minus m over p equals, I can split these guys up, mat times e to the, which we can just say c2 here. And even, I mean, we can even call this c to make it look a little bit nicer. And let's see, we can, next step, again, this is really just some more algebra, so I'm just repeating this guy. I'm going to write CE to the m times AT. And let's see, our goal is to solve for p of t, right? P is a function of t, so we can definitely, hopefully you guys can see that this is really 1 over n minus p if we split our fractions. And all right, again, doing some algebra. So we have, let's see, 1 minus, let's see, we can bring this guy over. So MAT equals M over P. And right, cross multiplying, doing some algebra, dot, 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 right, maybe one more step, we finally get the following. A nice mathematical model, right, that gives us the population as time goes by of, I think it was alligators we were talking about. So here we have our nice mathematical model. And so what was the question, right? This is obviously a general solution. And the question was, if we go back, so when do we get 10% of our threshold population, right, which is 12? Well, let's use this model. And we have the following. Well, we know from our given information way above, we know P of 0 is equal to 110, right? I definitely wrote that down. And so with our model, we have the following. We have, using this guy, we have 110 equals, my M is 120, right? That was our threshold population. And it's going to be divided by 1 minus CE, okay, raised to the M. So my M is 120. And I have times A times T. So times A, and then my T, right, is 0 because I'm using P of 0. But what's my A? Well, remember my A was actually, we have it, it's way above on the very first, the top of the page. But remember from 18, we did solve for A, and it was actually, what was it? It was A equals, let's see, P naught, not P naught, just kidding. It was B naught over P naught squared, right? If you look, we have this on 18 and of course at the top of the page. So we can actually find what A naught is, well, or what A is. So what's B naught? Well, B naught, according to our given information, B naught is 11, and over, and my P naught obviously is 110, but I'm squaring it. So if you reduce this guy, you actually get 1 over 1100. So that's what my A is. And I know it's a little bit small here, but I'm inputting that guy right in there. But this is nice because, I mean, 0 times anything, well, all of this is going to be 0. And e to the 0 is going to be 1. So this is wonderful, right? We get 1 minus c, and then this is just a nice algebraic equation, and we know how to solve algebraic equations. So let me move this up. So dot, 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 you guys can cross multiply. When you solve for c, you're going to end up with negative 1/11. Okay, so why was this c important? Well, it was important because according to our model, right, we need that c in order to do anything with the population. So we have P of t, which is equal to 120, right, or M. And then I have 1 minus c, but my c is negative 111, so it's really 1 over 11 e to the m times a. Now m is 120, and a is, well, let me just go ahead and write it down. A is 120 times our a, which is 1 over 1100 from the very beginning, times t. And of course, when you just multiply these guys, you get a nice 6 over 55. Okay, so let's, we're almost finished here. So let's just move this up. And there we go. Okay, so the question is, when do we get 10% of our threshold population, which we found out in the beginning, which was, it was 12. So we know the sky, right? We want to set that equal to 12. So 120 over 1 plus 1 over 11. What's 1 over 11? Oh, it doesn't look nice. Let me rewrite that. 1 over 11 e to the 6 over 55 times t. And so this is just a nice equation. And you can write cross multiply to both sides. It really doesn't matter however you want to solve it. It's really up to you. If you cross multiply, let's see, you get, and after distributing, you get 12 plus 12/11 e, right, all of the sky, e to the 6/55 t, equals 120, and almost there, hang in there. So then we have 12/11 e to the 6 over 55 t, and then 108. And again, our goal is to find t, so I'm going to multiply by 11/12 to both sides. So 55t, and then I obtain 99. And let's see, I want t, so I'm definitely going to take the natural log of both sides. So natural log of this guy, natural log of this guy, and it's not there. That should be here. And then we're almost done. 6 over 55t equals a natural log of 99, right? And you're going to divide both sides by 6 over 55. So therefore, t is going to be 55 times natural log of 99, and actually over 6. And if we punch that in our calculator, we get approximately, so if we round to the hundredths, so 12 months. So how long, so when do we get to 10% of our threshold population? It's going to be 42.12 months. And that is the end of number 20. Hopefully that makes sense. Please let me know if it doesn't. If you need clarification on a specific step, just let me know the time, for example, at 8:38, you know, you didn't understand a certain step, and I'd be happy to maybe explain it in a different manner.